This is specimen paper 3, number 3. It says consider the differential equation dy dx equals 2e to the x plus y tangent x, given that y equals 1 when x equals 0, gives us the domain from 0 to pi over 2. Asks us, by finding the values of successive derivatives when x equals 0, find the Maclaurin series for y as far as the term in x cubed. Okay, so I just went ahead and wrote down on here the equation. They gave me an initial condition, domain, and this is from your formula sheet. This is the formula for the Maclaurin series. They did ask me to find it up to x cubed, so I will need one more term. I'm going to need x cubed over 3 factorial times f triple prime of 0. Okay, one thing I want you to notice is they have given you right here what f of 0 is. F of 0 is 1. Okay, so this guy right here I already know is 1. I can already get some points for that too, by the way. Okay, I also already know the first derivative. Okay, it's right here. So I'm going to go ahead and find dy dx and evaluate it at 0, 1. When x is 0, y is 1, and you need both of those to substitute in here. Okay, so this is going to be 2e to the 0 plus 1 tangent of 0. Okay, and tangent of 0 is 0, so this is just 2 times e to the 0, which is 1, so this guy is 2. Okay, so I already know that this is 2. And one of the things you guys tried to do sometimes was, in order to find the original function, you went ahead and took the integral of this. Okay, that can be done, but sometimes it's quite complicated and you might not need to. They are, in fact, going to tell us to do this later in the problem, but they're going to take us through step by step and give us some hints. So trying to do this right now might slow you down and cause you to lose a lot of time. Okay, so I'm just going to do it straight derivative ways. They gave me the original, they gave me the first derivative, evaluated at the 0, 1. Okay, so now I'm going to need a few more derivatives all the way up to the third. Okay, so the second derivative will just be the derivative of dy dx. Okay, so right up here, here's my dy dx. Take the derivative of this. So the derivative, no, oh, one more thing. Notice it has a mixture of x's and y's. Okay, so that's implicit differentiation. Okay, every time you get to a y and you're taking the derivative of it, you're going to have to add dy dx. Okay, multiplied by dy dx. Okay, so we're going to have the derivative of 2e to the x is 2e to the x. Okay, and then this is product rule, so you have the first, which is y, times the derivative of the second. The derivative of tangent is secant squared x, plus the second, tangent x, times the derivative of the first. Derivative of y is just 1, but it would be 1 dy dx. Okay, and I'm just going to go ahead and say y prime, just because it's a little shorter. I'm also going to go ahead and just evaluate it. Okay, you're evaluating at 0. That's what f double prime of 0 is, but when x is 0, y is 1. So you can just put in 0 and 1. Okay, so this would be 2e to the 0 plus 1 secant squared 0 plus tangent of 0 y prime. Okay, this is y prime at 0, which just happens to be 2. We already found that out. So you substitute in that value. Okay, so let's look what we've got. Tangent of 0 is 0 anyway, so that's gone. So this would be 2 times e to the 0, which is just 2 times 1, plus the cosine of 0 is 1, so the secant of 0 is the reciprocal of that, which is still 1. Square it, still 1. Multiply by 1, still 1. So 2 plus 1, we just have 3 right here. Okay, so we've got that. We're going to go on for the third and final derivative. Okay, the derivative of 2e to the x is 2e to the x. Okay, we're going to use the product rule on this guy. So we're going to have the first. Now this you're going to have to think about. To take the derivative, this is actually secant of x squared. So you're going to use power rule. Okay, so that means you're going to bring the 2 to the front. You're going to have secant x. Power goes down by 1, so it goes down to 1. Times the derivative of the inside. So the derivative of secant x is secant x tangent x. Okay, so all I've done right here, this is first times the derivative of the second, plus the second secant squared x times the derivative of the first. Derivative of y is going to be y prime. Still not done. I'm going to have to go down to the next line. Okay, I need to do product rule with this guy. So the first would be tangent. The derivative of the second, so the derivative of y prime is y double prime, plus the second times the derivative of the first. Derivative of tangent is secant squared x. Okay, so that's quite long, but all I have to do is substitute in 0, so that's not going to be too difficult. y triple prime of 0. Remember, you're putting 0 in everywhere. So you have 2 e to the 0. Tangent of 0 is 0. So this whole thing is going to go to 0. Okay. Secant squared x, so that's secant squared of 0, so that's just 1, times y prime we figured out was 2, plus tangent of 0 again, so that's all gone. Y prime is just 2, and secant squared of 0 is just 1. Okay, so it looks to me like we've got 2 plus 2 plus 2. So we have 6. So now if we go back up here, we figured out f double prime of 0 was 3, this part right here. We figured out f triple prime of 0 was 6. So this is my answer. I just need to simplify this. Okay, so I'm going to write f of x equals, and f of 0 is 1, plus 2x. This is 3. 2 factorial is 2, so I just have 3 halves x squared, plus this is 6 over 3 factorial, which is 6, so 6 over 6, so that's just 1 x cubed. Okay, now this, let's see how they said it, just find it that far, so that is the whole thing. Really, it's plus dot dot dot. It would continue. Okay, the next part, BI, says differentiate the function e to the x sine x plus cosine x, and hence show that this integral is true. Okay, so I'm just going to start with taking the derivative of this. This is just a product rule, so it's first times the derivative of the second. So the derivative of sine is cosine, the derivative of cosine is negative sine. That's first times the derivative of the second plus the second times the derivative of the first. Okay, it doesn't quite look like anything I have here. What I'm going to do is look at this as two terms. Terms are separated by plus and minus. These are multiplied together here. These are multiplied together here. Okay, so I'm going to factor out an e to the x, and that would leave me in this first term cosine x minus sine x. E to the x out of here, we'd have plus sine x plus cosine x. Okay, and these little guys right here would cancel, so cosine x plus cosine x is 2 cosine x. Okay, and if you look, that's so close to what I have here. Okay, so let's look at what this means. I have that the derivative of e to the x times sine x plus cosine x equals e to the x 2 cosine x. Well, what that means is if I integrate this, I'll get back to here. These are inverse operations. So I have the integral of e to the x times 2 cosine x would give me e to the x sine x plus cosine x. Okay, and if you look, they want me to show what the integral of e to the x cosine x is without a 2. Okay, so we know this 2 could come right outside, so you're just dividing both sides by 2. So you have the integral of e to the x cosine x would equal, dividing by 2 is the same as times a half, e to the x sine x plus cosine x. And c divided by 2, in this case you're fine to just go ahead and say c, and so we have completed BII. If I didn't have this, I would really be looking at integration by parts to do this if they hadn't asked me to go in this direction. And they're trying to do that to help us on the next part. So the next part says, find an integrating factor for the differential equation and hence find the solution in the form y equals f of x. So it has to be solved for y. They are asking you to solve this using the integrating factor. And because they gave you an initial point, you're going to have to solve for that c. Okay, so we're just going to start with that. This is II. Okay, and so we have dy dx equals 2 e to the x plus y tangent x, and y equals 1 when x equals 0. Okay, now if you look on your formula sheet, it tells you what to do for integrating factors. Okay, it tells you if you're in this form, that your integrating factor is e to the integral of p of x dx. Okay, so you need to get this in that form. Okay, dy dx is the same as y prime. You're going to bring the term with the y over, and I'm going to write this as plus negative tangent x times y equals to e to the x. And I did it that way because whatever's in front of the y is the p of x. Okay, and if I leave off that negative, it's going to mess me up. Okay, so let's find our integrating factor. It's e to the integral of negative tangent x dx. Okay, e to the integral of p of x. To integrate tangent, you're going to want to change that to sine over cosine. And it's still negative. And this is basically one of your ln ones. Okay, you're using u is the denominator. This looks like du over u. Du is negative sine x dx. Okay, so this is really, if I just look at this part, that's the integral of du over u, which is the ln of absolute value of u. And that'd be the absolute value of cosine x in this case. Okay, for integrating factors, we generally do not use the absolute value or the plus c. So this becomes e to the integral of ln of cosine, absolute value of cosine x. These are inverse operations. The e and the ln undo each other, and that just leaves you cosine of x. So that's your integrating factor. What do you do with an integrating factor? Well, you multiply both sides by it, and then you integrate. That's why you call it an integrating factor. So multiply both sides by cosine x and integrate. Okay? And when you do that, this whole side over here, the whole left-hand side is going to turn into y times the integrating factor. Okay? So that for us would be y times cosine x. That's the secret on this. The right-hand side, you just have to actually integrate. Okay, and I'd be thinking integration by parts, something like that, except they helped us out with that already. Okay, they told us what the integral, they had us work out the integral of e to the x cosine x. And even if you didn't, you could borrow from this what it is. Okay, so I'm going to write y cosine x equals, I'm going to take out the 2. Okay, and they told me that e to the x cosine x is all of this stuff. So I'm going to substitute that in. Okay, and then I've got this guy over here. So I have y cosine x equals e to the x times, oh, sorry, I lost a sine x parentheses here, sine x plus cosine x plus c. Okay, you need to solve for c. Y is 1 when x is 0. Okay, so you have 1 cosine 0 equals e to the 0 sine 0 plus cosine 0 plus c. Okay, cosine of 0 is 1. This is 1. Sine of 0 is 1. Okay, so when you solve this out, c is 0. Okay, so now we've got y cosine x equals e to the x sine x plus cosine x plus 0. Okay, so all you have to do now is solve it for y, which is just dividing both sides by cosine x. Okay, you could leave it like that. You could divide each of these by cosine and get tangent x plus 1, sine over cosine plus cosine over cosine. Okay, you would get full credit for either one of these.